Hello, in this lecture, we will cover the mass spectroscopy of elements. The atomic number of an element is crucial. It indicates the number of protons in an atom's nucleus, which defines the element. For example, helium has an atomic number of 2, meaning every helium atom has 2 protons. The mass number is the sum of protons and neutrons in the nucleus. For example, a carbon atom with 6 protons and 6 neutrons has a mass number of 12. Since elements are defined by the number of protons in the nucleus, the number of neutrons can vary even within the same element. The mass number of an atom is typically shown at the top left side of the element's symbol. Isotopes are atoms of the same element with different numbers of neutrons, hence different mass numbers. For example, carbon-12 and carbon-13 are isotopes of carbon. Potassium has 3 naturally occurring isotopes: potassium-39, potassium-40, and potassium-41. However, potassium-40 is radioactive. Banana contain potassium, including a tiny amount of radioactive potassium-40, making them slightly radioactive, though not harmful. The average atomic mass of an element is the weighted average of the masses of its isotopes, based on their natural abundance. For example, potassium has an average atomic mass of 39.1. To find the average atomic mass of an element, we consider the masses and abundances of its isotopes. For instance, carbon has 2 major isotopes, carbon-12 and carbon-13. Carbon-12 has mass of 12 AMU, an abundance of 98.93%, and carbon-13 has mass of 13 AMU, an abundance of 1.07%. First, we multiply the mass of each isotope by its abundance, not by percentage, but by decimal. Next, we add those numbers. So, the formula for average atomic mass can be generalized as AMU, or atomic mass unit, is a unit of mass used to measure an atom's mass, which is defined as 1/12 of carbon-12's mass. So carbon-12 has a mass of 12 AMU by definition. However, the mass of an element in AMU, or atomic mass unit, is not exactly the same as its mass number. For instance, helium-3 has a mass of 3.016029 AMU, not exactly 3. So, when a value of isotope's mass is given, always use the provided values. When not, it is generally safe to approximate the mass number as an atomic mass. Mass spectroscopy helps determine isotope abundances. It separates isotopes based on atomic mass. In the mass spectrum of magnesium, peaks correspond to different isotopes. The height of each peak represents the abundance. By analyzing the peaks, we can determine the relative abundances and masses of the isotopes. For example, a larger peak for magnesium-24 compared to 25 or 26 indicates a higher abundance of magnesium-24. Answer is in the description of video. Thank you for following along. In the next lecture, we'll delve into atomic structure and electron configuration.